Okay, so remember we're looking at the statue from one angle, the algebra 1 angle, so that we can look at the statue from the algebra 2 angle and connect it together to give us a more full picture of what we're doing, right? So we looked at solving systems of equations by graphing and substitution in the last lesson. Today we're going to review solving by elimination, which will lead us down the pathway to being able to kind of spin over here in the next lesson and start to take an algebra 2 look at some of these. Now, I want to make some edits to these instructions because I want to clarify them, but also I kind of, I have a way that I do these things that I think is maybe probably better than this. So that's just my suggestion. So make these notes with me. So the first thing that I want you to do is I want you to line up the equations, and by that I mean vertically. So we're going to line up the equations vertically, okay, and we're going to put the variables in order above each other. So x is above x's, y is above y's, constants above constants, like that. Now, this says multiply one or both equations to get a result in a variable with the same coefficient. I'm going to recommend that we change that to opposite coefficient. Again, coefficient is the number part of a variable term, right? It's the quantity. Like 5x would be 5 boxes of x. 5 is the coefficient part. X is the variable part, right? That's our language there. So we're looking for the opposite numerical part of a variable term, okay? Then we're just going to cross this out right here. We're just going to add the equations to eliminate those variables that have opposite coefficients, like positive 4x and negative 4x. You add positive 4x and negative 4x, they go bye-bye, which is the whole idea of elimination. Right? That's the whole concept that we're working with. And then we'll solve for the remaining variables and then substitute back in like we did with our substitution. Okay? All right, so let's start with number 2. Okay? So first thing you want to do is you want to take a look at your equations, make sure they're lined up vertically, x's, y's, constants, like that. All right, we're good to go in that situation. The next question you want to ask yourself is do I already have opposite coefficients on either of my variables? In this case, I do, right? It's on the y variable. We have a positive 2 and a negative 2 y variable. So what that lets us do is set this up as one big addition problem. And then what we're going to do is we're going to just take each column and we're going to add it straight down. And when we do that, we get 8x and then plus 2y minus 2y, that's going to be 0y, so we'll just cancel those out. So 8x is equal to 64. And now we can solve for x, right? X is equal to what? 8. All right, good. Now we got one of our variables for our solution, right? So that we're just going to take that and we're going to plug it back in. We can use either of our other 2 equations. I'll just use the first one. So 3 times 8 plus 2y is equal to 22. 24 plus 2y is equal to 22. Subtract 24 from both sides. 2y is equal to negative 2. Y is equal to negative 1. That's pretty easy, right? Okay. 8 comma negative 1. And which classification would this one be? Independent and consistent, right? And we're not going to write that on all of these because the whole point of us solving these by elimination is we're going to find mostly that these are going to be independent, consistent. So for this lesson, we're just going to solve them and we'll let it go down. All right, that's pretty easy, right? So when you have existing opposite coefficients, you just move right into adding your 2 equations together. Elimination. Okay? All right, let's take a look at number 1. Okay, so we've got our problems. They're lined up vertically. That's what we want to see. That's nice. Do we have opposite coefficients? No. But we have same coefficients on the x's, right? So we could easily create opposite coefficients by simply multiplying through by negative 1 on one of the equations, right? So if we just take one of these and we multiply both sides by -1. I should do another parenthesis there. And then I'm going to rewrite my problem. So when I multiply, I like to rewrite my problem. So now I'm going to have x plus 7y is equal to 17. And then my second equation is now going to be -x plus y is equal to what? +7, right? Now I have opposite coefficients. I can move right into adding. And now it becomes the same thing that I just did. So my x's are going to eliminate in this case. All right, and I'm going to end up with 8y is equal to what? 24. And y is equal to 3. Okay? Now, once we have one of our answers, then we can just go back and plug it in and find one of the other ones. And now you could use this original equation, you could use this transformed equation, or you can even use this original equation right here. You'd use any of them because they're all the same. They're just like, it's just like 1/2, 3/6, 4/8. It's all the same thing. They just look different. They've been manipulated equally on both sides of the equation, right? So in this case, I think it would be just as easy to go x minus 3 is equal to -7. Add 3 to both sides, we get x is equal to -4. And then just as you're solving these, make sure that you write them in the right place. Because we solve for y first, right? So just keep that on the radar. And so as you're solving these, make sure that you write in those letters. Okay, so if you have exactly the same coefficients, then just pick one of your two equations and multiply through by -1, and then it's an easy peasy problem. Any questions so far? Everybody good? This is easy, right? Should be. Let's do number 3. Okay, so do we have opposite coefficients on one of the variables? We do? No, not yet, right? And we can't just multiply through by -1, right? So then the next question is can we turn one of them into the other? Like, could I turn a 2 into a 7, or could I turn a 3 into a 6? Well, the easy answer to that is 3 and 6, right? But I've got same signs. I don't want the same sign there. I want opposite signs, right? So what I've got to choose to do is multiply through here by what? Yeah, I'm going to multiply both sides through by -2. So I'm going to rewrite my problem. So now I've got 7x minus 6y is equal to -53. And then -4x plus 6y is equal to +26. Yeah? And then once I do that, I'm ready to do my big addition problem. Okay, you finish it up. Come up with -9 and -5/3. Okay, so let's talk about fractions versus decimals, all right? Generally speaking, for this class, you're going to see me use a lot more fractions than decimals. Plus, that's really a more accurate answer because if you have to do math with that, you can do math with common denominators, that kind of stuff. Whereas if you put it with the 0.3 and the vinculum, that's really an approximated answer, right? That's going to be a little bit harder to do math and get it accurate. And so we'll be doing more fraction math in this class. And so I would say stay in fractions. So, yes, ma'am. Yes. Because -1 is not going to create the same coefficients here to allow me to eliminate my answer. So I'm always looking to create opposite coefficients, right? So that when I add them straight down, they eliminate. So I can turn a -3 into a +6, which will cancel with that -6 by multiplying by -2. So that's what you're looking for. You're looking for what's the easiest way for me to create a situation where I have opposite coefficients, like we wrote down above, so that when you add them straight down, they cancel out. Okay, that's what you're looking for. Okay, any other questions on this one? All right, then let's take a look at 5. Okay, and it's just a progressive check through, right? It's like, do I have opposite coefficients right away? No. Can I create them by multiplying through by -1? No. Can I turn a 2 into a 5? Not easily, right? It'd have to be fractional, right? Can I turn a 3 into a 7? Again, not easily, right? And so in that case, I'm going to have to multiply both equations by one number to create this least common multiple of what we're looking for. And in this case, I tend to go with the smaller of the two numbers. It doesn't really matter which one you use. So what would be the least common multiple for 5 and 2? 10, right? And what's the least common multiple for 7 and 3? 21. So I can either choose to operate with the 21 or I can choose to operate with the 10. Your choice, but again, I'm going to err on the side of smaller numbers. So I've got, if I turn these into 10s, one of them I'm going to have to make negative, right? So that they cancel out. Because again, the goal is to create opposite coefficients to eliminate one of the variables, right? So you go ahead and do it. Let's see what you can come up with. And let's see how you do. And we'll just kind of talk about it when we get done, all right? Give it a shot. Stick with the 5 and the 2, though, all right? And let's see how you do. Go ahead. Should have come up with -2, +1. Take a look. Right, and it doesn't really matter whether, like I chose to multiply through by -2 at the top. Let's say you chose -5. You would have just ended up with -y is equal to -1, which you would have then divided by -1 and gotten y equals 1. Okay? But again, the idea is that you're turning both equations into a situation where you have opposite coefficients, and then once you have opposite coefficients, then you can do your addition problem. What do you think? Want to do one more of those, or are you good? 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 You're going to get some more practice on these, so. Because really, what we need to talk about, word problem. Okay, all right, here we go. Let's go to the back side. Okay, so you'll notice here with applications, because this is where this really comes into play, okay? You'll see the blend of comparing two unique items, so sort of a standard form-ish type problem, but yet this kind of breaks the rules of standards form because a lot of times we end up getting fractional coefficients in here, but you'll still see this idea of comparing these. But I do absolutely 100% want you to do this right here. Box it, highlight it. This is a must do. Write it down. You need to define your variables for these problems. Then you're going to set up two equations, think standard form, just maybe not necessarily following the rules about, no fractional values. You can have fractional values, but it's going to have a standard form kind of vibe to it. You may have some substitution type vibes too as well, but you're going to set up two equations, and then you're going to solve those systems using either substitution or elimination. We're not going to bust out graph paper and try to solve these by graphing, okay? So we can use substitution or elimination to solve these, whatever seems to be the more logical pathway. Okay, so let's do one together. Okay, Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. The books cost $1.50 each. The CDs cost $5 each. How many of each did she buy? Okay, let's start by defining our variables. So I'm going to use B for books. And I want to be clear that this is an amount. This is the number of books she bought. And I'm going to use C for CDs. And again, this is an amount, the number of CDs that she bought. Okay, talk amongst yourselves. Okay, let's try to come up with an equation that uses the information in the problem with these two variables, and let's see if you guys can come up with an equation that we can use. Go ahead, just talk about it. We got to come up with two of them, but Let's see what you talk about it, see what you can come up with.
Wait. 1.5 times plus 5C.
Okay. You have a chance to talk it over a little bit? Okay. Who wants to volunteer an equation? Anyone want to volunteer one? No? Dom? All right. What do you got? Tell us what you got. Just one equation.
1.5 B plus 5C equals 45.5.
45? 54. Okay. All right. Okay. So you said 1.5B plus 5C equals 54.50, like that. What does that mean in terms of the context of the problem? Like, where'd you come up with that?
Each book is $1.50. Each is $5.
Okay. So we knew how many books she bought and how many CDs she bought. We know that whatever she bought, she spent $54.50. Okay, good. Yeah, that's a legit equation. Okay. All right, we need another one. Who's got a second one? That isn't the same thing. Anyone? Second one? Scarlett, you want to take a try? What do you think?
Books plus CDs equals 20.
So B plus C equals 20? What does that represent in the problem?
Of how many books she bought and how many CDs, and that's like the total number of items.
Okay, that's a legit equation too, right? Right, because that represents the number of books and the number of CDs added together. Very good, right? And so we have two things we don't know, which means we need a system of equations, of two equations, two things, two equations, right? That's the way it works, right? We have one thing we don't know, we only need one equation, we can solve it. If we have two things we don't know, then we need at least two equations so we can solve it, right? So now that we have this set up, why don't you solve it? Go ahead, see what you can do. Okay, I got to keep going. So take a look and see how you did. Okay, now you'll notice that in the blue, I solved it by elimination. In the green, I used substitution. Either one is fine, okay? And so really, it comes down to your choice in that matter. So when it comes to these, you can use elimination or substitution for the word problems, okay? So whatever makes the most amount of sense for you to do, all right? Questions on that one? Make sense? So it's really all about defining your variables and then setting up the equations correctly. All right. Let's do number 10. All right, Landon babysits and works part-time at the water park over the summertime. Okay, babysitting, working at the water park. Okay. 1 week he babysat for 3 hours and he worked at the water park for 10 hours. He made $109. The next week he babysat for 8 hours, worked at the water park for 12 hours, made $177. How much does Landon make per hour at each job? Okay, let's define our variables so that we're all talking the same language. So we'll use B for babysitting. Okay, and what we're going to do is we're going to find, because look, here's what I want you to notice, right? In this particular case, we're given the quantity, right? We're given the number of hours that he works, the number of hours, right? So what we're looking for in our variable is the amount of money he makes per hour, right? That's what we're looking for. So in this case, our variables are not defined by quantity, they're defined by a rate. So this is babysitting in dollars per hour. So when we solve for B, whatever number we come up with, that's going to be, and he made that many dollars per hour. Same thing for the water park, right? So when he works at the water park, right, we're not solving for the number of hours he works. We already know that. What we're trying to figure out is how much money does he get paid per hour? That's what we're looking for. Okay, why don't you try to set up two equations that would work for this problem. Let's see what you can do. Okay, you should have put those two equations down right there. Right, and if you think about it, it makes sense, right? Because this time the coefficients are the quantities, not the dollar amounts, right? So in this case, we're talking about the quantities of hours. So then the variables represent the dollar amounts that get us from 3 hours of babysitting and 10 hours at the water park to $109. Okay? All right. Two standard form equations. Solve them. Go for it. Come up with $10.50 per hour at the babysitting and $7.75 at the water park. Yeah, we good? Make sense? Okay. All right, let's do number 11. Kent has a collection of pennies and nickels with a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? Question. Are we looking for an amount or are we looking for a value? Amount or value? We're looking for an amount, a number of question, right? So as we define our variables, we want to just make sure we're clear on that. So we know what we're looking for, and when we write our equations, it makes sense, right? So we could use P for pennies. And again, we're looking for a number of pennies. We know what the value of a penny is, right? Okay. And then we can use N for nickels. And again, this is an amount. Okay. All right, why don't you just take off and go? Just knock it out of the park. And I'll put the equations up in just like a minute or so, just to see if you're tracking with them, okay? And then we'll go from there. Here's what I came up with right here. You should have come up with that. Yes.
I did it differently, so we don't have to do it like decimals. We should put 1 penny and 5 nickels. Then we made our other number 198. And so then when it's time to like that, we'll just move the decimal back to places that shows.
As long as you make sure to move that decimal back. But if you don't move that back, then yeah, you're going to end up with, a different number of units. Yeah. Okay. All right. Everybody good? Which one's easiest, by the way, to use for solving this one? What do you think? Yeah, this is kind of set for substitution. Can you do it with elimination? Sure, you could. I mean, it's possible, but, I think it's sort of set up for substitution. But again. All right. Finish it up. Look and see how you did. Should have come up with 53 pennies and 29 nickels. How'd we do? Who got that right? Let me see. Just out of curious. Who got that right? Okay, good. Okay. So the trick would then be, of course, to take a look at these and, ask yourself, hey, what did I do wrong? Where did I get off track? If you didn't get them right. Okay. Homework. Yes. We're not going to do all of these, so I'm going to let you know which ones we're going to do here in just a second.
We're just banging out with that.
All right. So 1, 3, 5, and 7 on the front side. 1, 3, 5, and 7 on the front side, and then we're going to do the back side, the whole back side, 9, 10, 11, and 12. Okay, so here's what I'm gonna do for you. Yes. No, you're doing 1, 3, 5, and 7 on the front side. Just the odds on the front side, but then the whole back side. Okay, so in like 15-ish minutes or so, maybe less if everybody wants to just do this like together, we can do that. I'm going to put the equations for the backside up on the screen so you have an idea, so that like when you go home, you're not like, oh, I'm totally stuck on, putting together the right equation, okay? But I want you to do it first. So what I would recommend is leave the front side to do later, because I think you can all do the front side, and start working on the back side right now. At least get the equations for the 4 questions on the back side down and your variables defined, okay? I'm going to use X's and Y's for my variables, but I'll define them by whatever they are, like whatever thing I think they are. So I'll put that up for you in just a little bit, and then you can at least make sure you have that so that you're moving in the right direction, okay? All right, so go ahead and start working on the backside if you want those equations. If you don't want them and you just want to do it all on your own, then you do whatever you want in terms of, your pacing right now, okay? All right. With 9 and 10, so here's what I came up with for 9 and 10. And again, you can use different variables than I do. That's okay. Good. Everybody cool with that? Any questions? All right, let's take a look at the next one. So here's 11 and 12.